Did you get my email with the exam in it? Excellent. Today we're scheduled to get started on a new project, our problem-solving project of the slow-moving car. Before we start this, I would like to know if you have any particular questions for me concerning the exam or the previous project with the bridge or anything else. Is there anything that needs to be figured out before we move on to the next thing? I'll be completely honest with you, I haven't been looking through things very well. I will take some time to look through everything and make sure that everybody's got it all turned in. Everything's coming in at different times from different students for me, since we have most of this class watching the video and doing it from that direction. But I will gather everything together and organize everything and see what I've got and see what I'm missing, and I will get back to you on that. I'll get back to everybody on that. And we will make sure that everybody has everything that they need to have in. So I will check on that. Any other questions or concerns? Okay, well, let's go ahead and take a look at the next project. In the next project, we're going to treat this kind of like a real engineering project where I'm going to tell you what I need, and then you are going to ask me questions, as many questions as you think are necessary to solidify and to clarify and to focus in on the problem. So I'm going to give you a statement and you're going to ask questions and take notes on the answers until you have a clear idea of the objective, a clear idea of the problem, and enough to get going on creating a solution. So, having said that, I need a slow-moving, mechanically powered car. That's my need. I need someone to design me a slow-moving car that is powered by some mechanical device or some mechanical mechanism. Do you have any questions for me? Because I'm going to have a race for cars, and the race will not be a race to see who's fastest, but a race to see who is slowest. Now, for those of you watching this video, later on you are going to be required to ask some questions of me, and that means that you will need to ask them by email. Even though you cannot participate in this discussion at this time, you will be required to participate in it by email so that I can answer your questions as well. So if you're watching this video, write down a question as soon as it occurs to you and email it to me, even if it gets asked during this video after you've written it down. If it gets asked in this video before you've written it down, do not ask the question. But while you're watching this video, ask your questions, send them to me by email, and I will know that you have participated. Okay, go ahead. Any other questions? So materials that you can use. I would like this car to be made from the materials that I have provided you in your materials package. it's important to realize that you do have wheels and gears and pulleys and rubber bands. You have some really wide rubber bands. You may be wondering why they're in there. The really wide rubber bands, if you stretch them over the wheels, they make a nice little tire for that wheel, so that you can make the wheel grip something a little bit better. Now remember, we're asking questions less about the design, because asking what materials we can use is a little bit more about designing than it is about the problem. Right now we're trying to clarify the problem statement. So far what you know is that the car needs to move slowly, and that it is it's for a race, but you don't really know many details beyond that. You need to know some more details. Because you need to, I mean, what does slow mean, for example? What kind of, I mean, we got questions to ask, so. Okay, so I think that I think what we will do is we will race these cars against each other for time, and whichever car goes the longest time without leaving a 2-meter diameter circle, but also without stopping, will win the race. So we'll draw a circle that is 2 meters in diameter on the floor. We'll release the car at the edge of the circle, with one wheel at least touching the edge of the circle. And it won't matter which direction it's released in, but whichever car stays in that circle the longest amount of time without stopping will be the winner. So that's how slow. That is not, that doesn't matter to me. All I want it to do is to stay within the circle for as long a time as possible without stopping. I don't care if it goes straight or turns or whatever. Very good question. You are probably the first student, I think, in 3 years to ask that particular question. And it actually opens up a lot of possibilities, doesn't it? I do not. I do want it to be stable. In other words, I don't want it to fall over or anything like that. But I don't care besides that, how many wheels it has. Do you have any other questions? Yes, you may. Okay, those were good questions, and I think that from those questions you could probably put together some kind of a problem statement that is pretty accurate to what I want. And I like where that went. It doesn't necessarily take a lot of questions to figure out what is needed. From here, though, we would like to go to page 130 something maybe. No, maybe not quite that far. 119. And remember a little bit about the design process. The design process is mapped out on 119. And this is a process, a 10-step process, and I want you to provide evidence that you have followed every one of these 10 steps. You should probably have 10 pages, each page with image and maybe some writing or an explanation of how you fulfilled this part of the process. And right here in step 1, we've done the first step already. We've identified the need and we've defined the problem. Well, you're well on your way to it anyway. As I talked about what I wanted, and then you asked questions, you got a lot of details and information about this project, and you should be able to at some point here in the very near future, today, before this class is out probably, you should be able to define the problem and I would just put at the top of your first page for this project, I would put identify the need and define the problem, write down all your questions that you asked, write down the notes that you took about the answers, and then at the bottom make a problem statement. Okay? And that is going to be the first part of this project. I thought about making a 10-page workbook for this, and I may do it still, but I'm trying to get all of you to kind of do this on your own, in your own style, in your own way, and organize it, learn to organize something. So these 10 pages are going to have, you're going to have one page for each of this process during this project. You can keep them all in a folder, you can keep them all in a Word file on your computer, I don't care how you do it. But the next step, of course, is to assemble a design team. Now, instead of assembling a design team, since you only have yourself, you might, instead of assembling a design team, you might start to do step 3 by maybe making an outline or a schedule or something like this. We've got a week until next Friday to complete this, I believe, in our schedule. Let's check that really quick. Today is the 30th, and we have until Friday. We have till Wednesday the 5th, apparently. We could go till Friday if we needed to next week. But your job now is to, these 10 pages are essentially going to be kind of like a logbook or a journal of your progress through the design process, as laid out on page 119. Now, the best way to do this is to actually step through these process using the examples as your guide all the way through the end of chapter 5. So for step 1, you have 5.1.1, which talks about all these different types of things that needed to be done, these different projects, and how they define the problem. And then step 5.1.2, assembling a design team. Of course, you're not going to assemble a design team, it's just going to be yourself. But maybe you ought to, actually on page 2, let's go ahead and pretend we're assembling a design team. And let's talk about what kinds of engineers we might assemble to do this project if we were leading a team. So we're actually going to do that. And list the engineers, list the types of engineers, and give a short explanation, a couple of sentences, why you would hire those kinds of engineers to work with you. And then you go on to step 5.1.3. Remember that in your book there are lists of questions and lists of topics that you should consider as you're going through these steps. So pay attention to those and think about them and address them as necessary. In identifying constraints and criteria for success, we have things like budget, personnel, legal, material properties, and availability, off-the-shelf construction. And as you get into these steps, we will be meeting again. We'll meet again on Monday, for example, and you will be able to ask me questions concerning those things. Let's say that, for example, your question previously was, what materials can I use, right? Well, that is one of the questions that's you're supposed to address in identifying constraints and criteria for success. What are the material properties and availability? So what can I use? And they're also off-the-shelf construction. Things like this. What are the things that we can use for this project? Well, I've told you that, and that gives you a budget and everything else. You also know the time, because we've just told you the time. So you can make notes of all these things for step 3, identifying the constraints and criteria for success. Now, in order for you to complete this project properly, you're going to have an idea or a plan for getting it done on time. You want to start, the the part of this project that is going to take more time probably is going to be, well, probably about half the time is going to be building and testing it. And so you want to save at least next Wednesday, next Friday for building and testing, and use today and Monday for all the preliminary work and the designing and everything else. And this does include, if we go back to our thing here, it does include searching for solutions. That means that you need to get online, you need to look at model cars, you need to look at maybe rubber band powered cars or other kinds of powered cars. I mean, I've given you rubber bands and I've given you gears and pulleys. There are other possibilities for powering this car, but probably rubber band are your best because you've got those materials. They're easily designed and easily used. So you're going to have to start looking at designs for rubber-bound powered cars and getting ideas, and then you're going to have at least 3 solutions that you think at the end of your research that you think are good. 3 designs, 3 sketched out designs sketched out on graph paper, and those should be on your page. That would be page page 4 of your book. Would have 3 solutions, 3 possible designs for your car. And then, of course, in 5, you're going to analyze those solutions just like we did with the bridge, and you're going to choose the best one, and that will be page 6. And page 7, you're going to have specific things about your solutions, right? And page 8 is going to be essentially a page that shows me your solution and all the particulars about it, and you're going to have to show that to me because I'm management here. And then, of course, page 9 and 10 are going to be little journals about how you have constructed the solution and tested the solution. So there's a lot to do. We've got 4 class periods to do it and a week to work on it. And this is the next project. I'm going to just kind of turn you loose without much more instruction because I want you to try to follow the steps that we used in the bridge design and the steps that we've been studying in the book to create your own organized kind of workbook similar to the one that we used for the bridge. Okay, and it can be more than 10 pages, but it should be at least 10 pages of kind of typed work. Eventually, I want the workbook to be typed in Microsoft Word or something similar so that it comes out very nicely. If you want to start off with writing it by hand, that's fine, and copy it into the computer later. That's fine. So, any questions before we turn you loose? Okay. Just so you know, this is very similar to the format that we will be seeing for the rest of the semester. We will have a day or 2 that we spend on chapter 6 before the last half of the class. But the last half of the class, we will start a project like this. I will give you some basic ideas. You'll ask some questions. We'll start you off on a workbook or what I'm going to call a log book, where you're going to log all the information and all your ideas and all your work that you've done. And then we'll meet every class day to just answer questions and clarify things and help you out with things. And then I'll just turn you loose again. We might spend 5 minutes in class, we might spend 30 minutes in class, but we will not be doing much more lecturing except for one day on chapter 6. And then we'll be done just doing projects after that. So, well, that's not entirely true. I lied. I forgot that in November, just before Thanksgiving, we will spend a week or 2 learning to do computer-aided design, and so we will do a lot of work together in class, learning how to use SketchUp. Have you ever used SketchUp before? Okay. Do you have a lot of experience with it? A little bit of experience? Okay, so if you've had a drafting class, this will be mostly review for you. We're just going to look at some very specific tools in SketchUp, how they can be used, and practice using them. We will still do that even if you have that experience, because I don't know how my other students' experience is in that, but we will be using SketchUp both to design something, but also to convert a design into a three-dimensional model on a 3D printer. So we will We will be doing that just before Thanksgiving, and then after Thanksgiving we will be printing models from our three-dimensional designs. So anyway, we will do some more in-class work, but it will be nothing like really working out of a book. So if there are no more questions, I'm going to turn you loose. Get started on this project. Probably by Monday you should have 3 designs and should be choosing between them, so that by Wednesday you can start building and testing. All right? Have a good one. Please send me any questions or concerns that you have by email or by phone, and I will get to you, get to help you. All right? See you later.